Hello everyone, and welcome for today's lab where you will study about objects that belong to a certain schema. Then you can use subqueries such that you can return your data. Also, based on it, you can also manipulate it for further usage. You can also manage how users can access your data, as well as it can be placed in different time zones. So let's see. First of all, you can also put a constraint. Here you can have the column which is commission of type number of 2, so you have 2 digits after the comma. And for the table employees 2, you want it to have a constraint such that for your table, this is why you got the keyword my employee, you have a check constraint, CK for your com, and you want it to be greater than 0. This is how you can also have a constraint on it, as well as you can also drop a table without being able to restore it. You've seen the case with the save point, but in that case, with the save points, you are able to do it. But here, when you have the purge, you will not be allowed to have it restored. Then what you can have is based on an employee's last name, department name, and salary, you want them to be matching the values for those employees who earn at a certain location with an ID equal to 1,700. This means that you have the aliases as before. Don't forget that for the table employees, you add the aliases being E. Then for departments, you join it based on D. And the link between the tables is that the employee's department ID as a foreign key needs to be equal to the primary key of departments. And what you want to have is the employee's last name, a department name which is taken from department, and the salary of your employee. So this is why you have E dot last name, D dot department name, and E dot salary. Then for it, you see that you want to have the salary and job ID to match the salary and job ID of any employee who works at a certain location with this ID of 1,700. So it means that you create a pair between salary and job ID, and you want it to be inside the set. So this is why you've got this in. And inside the set, you need to select the same two values, salary and job ID, which you take from employees, joining it with departments, and you do it based on the previous criteria, knowing that E the department ID needs to be equal to D the department ID, and you want the location of your department to be is 1,700. So you create pairs of this type with salary and job ID, and you want them to match another pair with job, with salary and job ID. But you have an extra condition as location ID should be is 1,700. So what is evaluated firstly is the subquery, and then you can evaluate the outer query where you've got this restriction within. Okay. Let's see. For this one, what you would receive is in fact all those we have this matching according to your location. So you have another restriction. Okay. Then what you can have is maybe you have multiple records. So here it is when you have a set, when you create a set. But what you can do is to have the employee's last name, job ID, and salary. And for them, you want them all to have the salary greater than those who work as sales managers. Okay, and sales managers, they have their job ID as being SA man. So it means that you need to compare the salary with all the records, so with each and every record, okay, that you've got here inside the subquery where you did select the salary of your employee and you want the job ID to be SA man, as well as you want to have all the salaries from highest to lowest, so you order according to salary in decreasing order. So in this case, you will obtain last name, you have your job ID, as well as you've got the salary. Okay, and you compare it according to every record which is returned by your subquery. So this is where before you were using in as having two values which you check whether they exist inside the set. Here you compare your salary with each and every record that you've got here inside the subquery. Then what you can have is also to compare it to the average salary. So here you want the employee's last name, salary, department ID with the average value for the salary for that department. Okay, and this is the case when you put this aggregate function. Then you take it from two sides. You have employees E and employees A. As you can see that you have this average salary. So this is why you call it for employees A, this alias. And you link the two employees, knowing that their department ID is the same. Okay, so they have the same average in their department. And you want the salary to be greater than the average for those employees who work in the same department as the rest. And you want to group everyone by last name, salary, and E department ID. And order according to the aggregate function, which is the average salary. Let's see. So you take them one by one as having employee name, employee salary, department, and average value. But you want the value of each employee, the salary of each employee, to be greater than the average salary. So this is why you have this subquery where you compute the average salary of employees, where the department needs to be the same. So department ID is the same as the one of employee, this E, the E which is here. Okay, and you take them one by one. Okay, and this A, it is for the average salary, okay, because you have multiple records. And you also group according to last name, salary, and department. Okay. So this is where you compare according to a value, okay, salary with the average salary, but it is not the general average salary, it is the one corresponding for a certain department ID. So as you can see, you have the value, the salary of each and every employee, and their salary is greater than the one of department average. Okay, like this. So same department. Okay, and it is great. Okay. Then what you can have is to check whether it exists or not. So here you want those employees who are not supervisors. So it means that you have an employees that belong to the outer set and you want them not to exist inside the inner set. So it means no matter what you select the rows from employees with inner, you want the inner.manager ID to be equal to outer.employee ID. So here, this is in fact that you want to find all of them who are not. It says that it should not exist inside the set which is computed. Okay, so in this case, you have them one by one. So this is in fact your subquery, okay, where you take every employee, as you can see, this inner, okay, and the inner, it looks like the inner.manager ID. So it is a worker having the manager ID equal to the one of the outer. Okay, so this is why they they are supervisors, but you want to exclude them. So by having every record, you want to exclude those who are supervisors. So this is why you have not exist. Okay, so this is another way of doing it. Or you can have it where it exists. So it can be those employees with their last name, and you want to see whether they have one or more co-workers according to the same department, okay, but you also want to compare according to their hire date, okay, to be later, and also to have higher salaries. So let's see, you select last name as you take from employees outer, and you want them to exist, okay, so you do have one or more co-workers. So from employees outer, you do the where exists, and you take your record X, so what you have inside. This is the meaning of it. From employees, and then you have this employees inner. What they should have in common, the inner and the outer set, okay, of employees, is that the department should be the same, such that the department of inner is the same as department of outer. Then you want the hire date of inner. It says that it will be later, so it needs to be greater than the hire date of outer. And you also need to have the salary to be greater. So again, the salary of inner is to be checked to be greater than the salary of outer. Okay, and this is how you get your records. Then you can also store the value with this summary. So here is according to the department name. You have a department total salary cost, and you want it to be above 1/8 of the total cost which belongs to the company. So in this case, you store it inside the summary. So let's see. Okay, let's have it one by one. What happens here? Okay. So in this summary, you would store. Okay. All right. You have from it, you want to display a department name. So from D with the alias, you take department name. Then you also want to have this cost of the salary. Okay, it's being department total. Okay, total salary cost. Okay, and you will do the sum of the salaries. Okay, according to the department. Then, based on a certain department name, you would join employees E with department D based on the current department ID, which is the foreign key for employees and the primary key for departments. What you do here is to group them all according to the department name. Then, having both of them, both department name and also you also have the salary, okay, is department total inside summary, okay. What you do is to take department name and department total from summary, but now you want the value of department total to be greater than, as you can see, you have the total salary cost. Total salary cost, okay, to be 1 over 8. Okay, so it means that you do the sum of all the departments, what you did compute before, inside summary. Okay, so this one you select the sum of department total to be 1 over 8 of your summary, and you compare each and every value, each and every pair of department name and salary according to the value of your cost, which is 1 over 8 of the total cost for salaries. Okay, and you will be ordering them in a decreasing order according to department total. Okay, the second column. So let's see. Okay, so you will have just 2 departments which exceed this value. Okay, so if I put it, let's say, be less, okay, you will also see the other values. Okay, and this is how you filter them one by one. So don't forget that you group everything according to the name, and based on this total value of the salary, you compute it again using the output of your width. So as you can see, you have width salary, and you have this width salary S. Then you have the select. So first you compute the salary inside the subquery, as well as you can use it afterwards. Okay, when you retrieve data from it and you do the comparison criteria. Okay. What you can also have, you've seen this one with the check option constraint last time, when you did change it for a certain department, and then you were not being able to add, so to modify those rows. So what you can also do for controlling the access, you can also grant several options, like you have select, update, insert, for example. Here you can grant select, such that based on the table regions, you can offer this option for a certain team, and you will be granting the option with grant option. Then you can even take it away, so you can revoke, and you will revoke select on a certain table, which is regions, from a certain team. Okay. What you can do besides select is also manipulate rights, like you have the select, update, insert, according to your certain table. Then what you can have is to also insert values, such that here you can compare your salary to 20,000. So whether your salary is 20,000, then you want to insert inside a table called special cell the values which are employee ID and salary. Okay. You can also have salary history, and for the salary history, so whether it is not greater than 20,000, okay, you want to store it in 2 tables. You have it in salary history and in manager history. So if not, you have this else branch, such that it will insert values. Okay. Inside salary history, you have employee ID, hire date, and salary. And you also have the manager history, meaning that you store the values of employee ID, manager, and salary. Then you can even see what you have inside, but here with this select, what do you do in fact? You just add aliases for your records, because you want to insert all these rows, having them already taken from employees. Okay, and you want to have all the employees who are the first, okay, with their ID being less than 125, such that you rename employee ID as being emp ID, you rename hire underscore date as being hire date in one word, you have salary as cell, and the manager ID as MGR. Okay, and you take everything from employees where your ID is less than. And this is where, by having created all these tables with special cell history, manager history, you are able to do a block of insert operation. So this is why you have this insert all. By having cell emp ID higher date all taken from this select. Then what you can do is to also format the session, like you have a different date format, and you can have the day, month, year according to the hours, minutes, and seconds. You can even add the time offset such that here you can put it to be US Pacific. Okay, and you can also set the offset to be directly of Singapore, or you can put it to be Egypt, and this is how you take one by one. Then based on the time, okay, you can set the time zone, okay, to be -7 or +7 according to Greenwich time. And you can also see which would be the current day, the current timestamp, the local timestamp by taking it from Duo. As well as you can see according to a database, which would be its time zone, a session time zone, and you set it again, you take it from Duo. Then what you can have is to take the year from hire date, okay? So you have the last name of employees, as well as you want to see their year when they were hired, and you want to do it just for those from department 80. So you have here a function which is extract, and you get the year from hire date. So let's see for those employees from department 80. Select. Then you have the criteria over here. Okay, and we take them one by one. Okay, so as you can see, if you don't put an alias, you have exactly the name of your function. Okay. Then what you can have is to also add a session date format, like you want it to be with day, month, year. Some puts the month in front. Also, you can have a date type. So as you can see, you have a column date, and you can alter a table. Okay, like for example, a table called sample dates, and you want to modify a column. Let's say it is named date col, and make it of type timestamp. So this is how you change a value inside the timestamp to have its type. Then what you can have is to get an employee's last name taken from the table employees, and you also want to add another column which is called review. So review is called based on, and you set the values according to the year when they were hired, such that if you have the year 2008, it needs a review, or not, it doesn't need any review. So you can put, it will compare it according to the year that you provide here. So let's say it's 2021 to see that it needs a review. Okay, and if not, it will say that it is not this year. Okay, so this is how, based on a value, you can extract. For example, here you have the year, you take it from higher date, okay, and in this way you compare it with a value, and you have whether it's true or false. So you have the needs review between single quotes, or else you don't have it, and you need to close this case, okay, with and to name it as being a review. Everything is taken from employees, and you order it according to hire date. And this is how, based on the year, whether their hire date is a long time ago. So let's see. Let someone was. Seems not. Yeah, they were from. Okay, so we have persons who were hired a long time ago. So you would have to make a review for those persons. Okay. What you can also have is to check the years of service and to see how much it is. So we have a last name, we have hire date, we have the system date, and then based on the difference between the system date and we have this 15, so this is for years, meaning that whether the difference between system date and hire date according to it to have 15 years, okay, you will have based on the hire date 15 years of service, then you compare with 10 years, with 5 years, and you see whether or not they do need a reward. Okay. Let's see. So we have 10 years of service. So they will be splitted. Okay. Since you have last name, you have hire date, and you have the system date. So based on the award, okay, you will have to compute bonuses, and you in this way you see who needs to have their salary increase. Okay, and this is based on a comparison between system date and the years. Okay, so you have minus 2y minimum interval. Okay, and you compare this result according to hire date. Okay. So this is how it compares according to a system date. You have this, you want to have difference of 25 years for the year of your current date, and you compare it with the higher date, whether it is great. Okay. What you can also have for a table is to place composite keys. And for these composite keys, it means that you will have a constraint and you will have a foreign key according to multiple columns which they reference a certain parent table. So let's see, when thinking about patients who come to be treated, you will have a treatment code, okay, and this will be a sequence of 6 characters, and you wanted to reference the treatment code which exists inside the table which is treatment. Then you want to have a slot number, yeah, according to every date. You have a slot number, you know which person you are according to a certain date when you come to be just analyzed by the doctor. So you have a slot number, number of 2, and based on the condition that here you have a primary key. So the primary key here is a composite key, meaning that you have slot number, treat code, and date visit, such that for a date, you have just one slot number can be allocated and just one disease will be treated. Okay, so you have each and every doctor with a single specialization, okay, and based on it, you have a certain treatment code. So they come to be treated for a certain disease. And also for the same date, same slot, you cannot allocate 2 persons. Okay. Then you have also the date of your visit. The date of your visit needs to also be stored inside the table, which is visit. And you will have a slot number and a date visit. So this is from where you take it. And it needs to be referencing exactly these 2 columns according to the previous appointment to the clinic. And what you will have to do here as activity is to get the employee's last name, employee, so this department number, which is department ID, and salary. And you see here that you have of any employee who have the department number and salary to match. Okay, so you have this to match. You can have the in and you select again the salary and the department ID. Okay, of any employees who earn a commission. So you have this commission percentage is not null. So what you would have is to select. Okay, here you will have one by one. You have last name, you have department, ID, salary, from employees. Okay, and then you have the where column, where you have salary and department underscore ID in, and what you need to select here are the same parameters, salary and department ID. Okay, from employees, and you have another restriction. You have this where. Okay, you need commission percentage to exist, so you have it is not now. Okay, and you take it one by one. So you have, firstly, you do select the employee's last name, department, and salary. But now you want to add a constraint just on the two of them. Okay, and you want to have them matching to those persons who do have a commission. So this is why you have where commission percentage is not now. If I neglect it, okay, then you will have, as you can see, multiple persons. Okay, and this is how you restrict both of them, such that you get just those persons who do get a salary. Okay, I mean a commission percentage. So it would be these persons. Such that when I also look inside the object browser, okay, and I look at employees, data, and I have my records, I see that there are some. Okay, you have these persons who earn a commission percentage. So it is based on them. Okay, here you also have some records. You have 20 records. So they are compared such that you do have them in the same set. Look, where you compare the salary and the department ID. Okay, so by having them one by one. This would be the one. Then what you would have here for exercise 2 is to get the employee's last name. Then you have hire date and salaries for all those who have the same salary and manager ID as Mr. Kohar. So you would select, you have here hire date, salary, so last name, hire date, salary on employees, so take it from employees, and here you have salary and manager underscore ID in, and you want them to be the same salary, and here we would have employee. Well, in fact, for manager, which is Kohar, so now it depends whether this Kohar is an employee or a manager. So whether it's a manager, you will have the employee ID, where we have the last name like, and we have Kohar. Taking it higher, yeah, it's not high date, it's higher date. So here, okay, we have, then it's again a manager ID, and we get exactly that employee. So here you are having two scenarios. this cohort to be the manager. As you did see, it wasn't. It is simply an employee. And this is how you get them, as well as you see which is the set for it. So you take them one by one. Okay, so I will copy this inside, destroy it, and whether I want just this one with cohort. Okay, this is the salary and this is the manager ID for it. And based on it, you see that you have other two persons who have him as their, okay, who have the same set. I mean the salary to be the same, also 17,000, and the manager ID to be 100. So based on this set, you have these two persons for whom you take the last name, hire date, and salary. While for the last exercise, you want the employee ID. You have last name, okay, and department ID. For those employees who have the name of the city which begins with T. So this is where you have like T with modulus. So you have here select, you have employee ID, last name, and department underscore ID. Okay. You take it from employees, where department ID in, and you select again the department ID from departments, where location ID is taken from your locations. Okay, you select location ID from locations, but you will have the name of the city to be T. And this is found inside the table locations. See locations. This is the one, and in data, okay, you find it as being city. So let's see. So firstly, you do select what? You have employee ID. Okay, you have last name, you have department ID. Then you have from employees, where you have the department ID in what? In select of what do you need to select such that it does the matching? What do you think? It is the same column, okay. Also select department ID from, take it from departments, okay. And being here, you will have a where location ID in what? In another select. So you have here select location ID from locations. Okay, but this is without the constraint, and you get them one by one. But here I want it here to have where city like, and I want it to be with T models, to start with T. So this would be with Toronto, okay. So now out of all of them, we see which are those employees with last name and department. And we want the city to be starting with T. But in order to reach that T, you need to go deeper inside. So from employees, you enter departments. From departments, you enter locations. So this is why. From employees, you have department ID in, and you get all the department IDs from departments, but you want to have their location. So you have a restriction here to be taken from the table locations, And you also want the column with city to be starting with T. And this is how you place it, and you find out which are your employees. Okay, this is your fifth lab that you have